Hi, and welcome to my shop here. It's September 25th, and today we're going to take a look at two tube testers I just acquired. I'm a very lucky guy when it comes to tube testers. Somehow on my life journey, at this point I have 7 of these guys. 7 tube testers. I think I've only put money out for one of them, I think. Oh my gosh, look at this. So, some lovely information just stapled right into the lid here. I mean, that's a fantastic thing in itself. But of course today, all this information about all these tube testers and everything else is all available on the internet. Sometimes many times over. So look at this guy. This is a Jackswon tube tester. It's I think a very popular model from its day. It's the model 648A, which I think is a tube tester to have. Well, I've got one. And I think what makes this one a good tube tester to have is that it's really easy to use. Really easy to use. And that's what I'm going to do. I'm going to use it. So let's just look it over a little bit here before I plug in the tube. So now there are tube testers that use circuitry that actually measure mutual conductance. And some of that circuitry is or was patented, and other than the manufacturing, was Hickok, who came up with the most famous circuit for measuring transconductance, or whatever you want to call it, in a tube. And that circuit was licensed out to some manufacturers. So for instance, I have a Weston. Yeah, it's kind of buried there, but that's my Weston tube tester. That actually measures mutual conductance. This one doesn't. This is actually a souped up or highly improved emissions tester. So a lot of emissions testers are very simple. In fact, a simple kind of tube test, basically, can it conduct, and does it conduct anywhere near the right amount of current given a certain plate voltage. Not much more than that. This one is more complicated. It applies selected voltages to a screen, if there is one, plate, and things like that, specific to the tube under test. So it's a little more of a focused machine in that. Is it really worth talking about? I should just put a tube in, and as I test it, then all will be revealed. So along the way, while I'm working in my shop, I pull tubes out, and then I don't put them back in their proper box. I end up throwing them around here and there, and eventually they end up in a loose bucket like this. So all these tubes, I need to verify their operation. And maybe this is a good one to start with. 6F6. Why don't we try this? I'm not even sure that this is... I think this is a bad tube, in fact. So here we go. Now, I have already tested a tube on here. I know this works, or appears to work. So, oh, I guess I better plug it in. That would help. So the first thing we're testing is Niagara Falls. Yep, Niagara Falls is on. That's good. So it has a... control here. This is confusing enough that it ships with this tag, and this tag is still here. Can you believe it? So this is like a warning tag. This control indicates line voltage. So how does it do that? So it has a bunch of numbers here. 100, 125, 120, 115. So the 100 is actually all the way around this way. I guess you're starting about here, and you see the meter bopping up and down. You turn this until the meter hits the line mark. There we are. One more and below. That's about it. And then you can read it. So it's between 115 and 120, so it's 117 and a half. So apparently line voltage in here is 117 and a half volts. Is it really? You know, that sounds pretty realistic, because I'm not going to bother double checking it. You need to keep an eye on this while operating the tube tester. different tubes draw different loads and maybe change the voltage a little bit. Okay, so most importantly, well, let's dial in 6F6 here. So the way this roll goes, you go down in ascending numbers till it gets to the end of the roll, and then the ascending numbers continue up this way till you get to the top of the roll, and then you come over here and you come down this part of the roll. I think we're right at the end right now. Stop, stop, stop. The Jackswon Electrical Company, Dayton, Ohio. Printed, doesn't have a date. Okay, so 6F, so it's going to be over here. Six F6, one set of tests. Filament voltage 6.3, that's where it's set. Now there's 2 rows of buttons, and they just give you the button pushes for each row. So for the D roll, it's 1, 2, 3. And for the E, it's 4, 5, 6. The plate test voltage is set to 50. Or plate test setting, not to say it's the voltage. And then the last letter there, W, is the test button. Here's the test buttons. These 2 are release buttons. When you push these, all these pop up. So to do the test, we push the W. Up until that point, this meter reads in the center scale the whole time. In fact, it's gone up a little bit. Not sure why. My house line voltage may be varying a bit. There we are. Generally, I'm not using these to make precise measurements, and this would not be the tube tester to use to make a precise measurement, because it's not measuring the mutual conductance. It's going to measure the amount of emission or current flow through the tube and compare it to its own notes, if you like, on what is good and what is bad. So we do have this on 6.3. I think they even tell you, did they tell you which? No, they do not. You have to figure out which socket to stick it in. I think I found one. Now, like most tube testers, it has a shorts test here. Right now it's in the full test mode, so it's ready to test the tube. We'll go down the shorts test and we'll see what happens. This is the light to watch. If it stays on, we're in trouble. Yeah, that is flickering. It's out. 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 Now, the flickering light. It's not flickering now. Oh, yes it is. I can adjust this a little bit until it goes out. And I think I'm doing this right. I may not be doing this right. And it gives you an idea of the resistance of the circuit that's causing the light to flash. I'm not sure about this. Oops. 750,000 ohms. I'm not sure about that. How quickly can I get sure about it? Too many tube testers in my life. Shorts test. Turn leakage control fully clockwise. That's this one. Fully clockwise. Turn shorts test control to all points, tapping tube at each position. I didn't tap it. Now watch the shorts indicator. If the lamp flashes or glows steadily, the tube is shorted or leaky. Glows steadily. Now it was kind of flashing like that. Rotate leakage control counterclockwise until the lamp is just extinguished. This will be the leakage of the indicated element. If the lamp still glows when leakage control is turned to the 250K marking, tube is shorted or leaky somewhere below 250K. So right here it says 0.25 megohms. That's the end of the control. Can't go any further. Can't reduce it to 0. If it's in 2 or more positions, if it glows in 2 or more positions, it's between those elements. The amount of leakage can be tolerated and depend upon the radius. So they're pointing out that just because it's leaky doesn't mean it can't be used. It kind of depends what circuit it's going into and just how leaky it really is. little bit again. There we are. Now we're at 122 point. No, 120, 120, somewhere 120 or something. We're right between 120 and 125. Math is too tough for me. So we're ready to do the test. The test would be W. This is just a pass and fail test. Why? Oh, it's going down. My experience with tubes on tube testers, when you test them and then the test results start to drift downwards, that's not a good sign. And another thing we can do here is we can reduce the filament voltage one step and see if this really drops off. Well, it's not dropping off an awful lot. It's definitely dropping off. So in the case of this is an old tube. You can't expect like old men to run like 20-year-olds, but it doesn't mean they can't do something useful, like maybe fix radios. So I would not throw this guy out. It's operating. Certainly not a glowing response here. This is the 6F6E. It's a bit of an unusual version of this tube, and I have it doesn't denote it here. I'm not going to put it in the tube tester because there's something just a little different about that. But I have a where is it? I thought I had a metal one here. Defective metal 6F6. Don't see it. Let's try another tube. So this is a labeled tube, 6V6. I have these in another radio that I'm about 3/4 of the way through fixing. It's got a number tag on it because I've tested this in another tester and I have a record of its test result. So let's try it. 6V6. 6V6, 6.3, 1, 2, 3 again. It's the same settings. 4, 5, 6, 35. See how fast it is to set? I mean, you can see why. You're going to do a lot of tubes. This would be the guy to do it with. 6V6, everything ready? That is really fast. W again. Okay, short test. Watching the light. Well, the instructions say to tap the tube, but I don't normally do that. This is a life test, and instead of reducing this voltage, I could have just pushed this back, and I think it does exactly the same thing. And we'll try that on this tube. But we're ready. W. It's in the good. There we are. Now it has a percentage scale here. This is just below 100. This is at 90%. 100 is there. It goes up to 130%. Ooh, curious. So that tube tests good. Okay, another 6V6. And one right here. Number 9. It's flickering there again on the cathode. W. Still warming up. Now, if you're in the business of repairing people's radios back in the 1950s, you're kind of hoping that this will come into bad and they'll see you do the test. The meter pointing at the bad means you've just sold a tube. So this is an important sales device. W. Well, sir, there's a little bit of life left in your tube, but I'd highly recommend, unless you want me out here in a month or two, that we replace this one and we replace the other one too. Even though it tested a little bit better, it's better to have both these tubes renewed so they are similar strength in your radio, which would be true. I sell 2 tubes now. Get to take one of the 2 tubes and put it back in your box to go into somebody else's radio somewhere down the road. Let's try this test here. I'll push the button. What happens? Oh, this is a spring-loaded one. Holding it. I would think pretty much any tube is going to go down a little bit. It's how far down, and that's a judgment thing. And with experience, I don't have it. Down a little bit. But in my books, those 2 tubes are okay. I should, in my books, hey, this is in my books. Now, what if I just step over here to my pooter and see if I can quickly see this 6v6 tube. Just bear with me 1 second because I have the tube test results here. Quickly. Put these on the screen. Here we are. 6v6, tube number 9. Is that right? 9 and 11. Okay, so 9 was the second one. So in my earlier test, 9 shows up as quite good in the Weston. Better than most, and 11 also. So I picked 2 fairly high testing tubes, if you like. But on here, well, one of them tested, I guess you could say high, close to 100 here, and the other one, quite different. That's the thing. You must have heard about the man with 2 watches. Never knows what time it is. Well, a man with 7 tube testers never knows which tube is good. Okay, we'll kill that. And we'll move on to something else. Then I'm going to show you my other tube tester. 6SK7. Okay, 6SK7 TUV. 6SK7, 6.3, A1246, A1246, A, and on row E, A358, A358. Plate setting is 15. It's a 2-button push to generate the test. In you go. 6SK7, 6SK7. Now while that's warming up, I'm just going to look and see how many more of those I've got in this bucket waiting. SQ, SG, SJ, all different. Hey, there's the 6F6 metal one. I didn't spot it. So that's the only 6SK7 I've got kicking around here. My glory gosh, it is. Okay, shorts test. You need to do the shorts test to protect your tube tester. No shorts. And the test is W and Y, W and Y. Here we go. She's a winner. Okay, so great tube tester, very fast, and it doesn't look like it's got a lot of mileage on it at all. It looks like a low mileage machine. So a great addition. This is a popular tube tester. It's well known. People like it. I like it. But it's not actually measuring mutual conductance or transconductance. Any one of a number of other words to describe the kind of reverse resistance effect of a vacuum tube. The, if I can call it that. That's the coolest thing. This is still on there. This is your line voltmeter. I think what happened here is this confused a lot of people. I think that's what happened. so we had to put a sticker on it. Okay, now the next one. This is a repairman favorite. And why? Look at the size of it. So these are also well known and very popular tube testers. So this is a Sencor TC154 tube checker, otherwise known as a Mighty Mite. Can you read that there? Yeah, Mighty Mite, Sencor. This is the booklet. The booklet is attached in here. You can't get it out. Well, you can see it's taken a heck of a beating. This looks like a well-used unit. Again, I've already tried this, so I know it works, or it appears to work. It's got 4 settings. You notice on this one, there's writing, 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 no writing. What happened to the writing here? It's literally rubbed right off and gone. And someone has scratched it. I don't think you can see it in the camera. You can see a little bit here. Someone has scratched in the letters that have been rubbed off. This is an important control for doing the shorts test. So it gets rotated all the way around. And I think, you know, because it's used so much, it's just all the letters are gone. You can just see a little tiny black piece of one right there. That confused me for a little while when I first looked at it. The other thing about this guy is there's no tubes inside it. This is a solid state unit. So we'll pick 6V6. Here we go, 6V6. This is a very simple emissions tester. 6V6. This book won't last much longer. But thank God we live in the internet age, because I'm sure this information is available on the internet. 6V6. I guess this is the alternative to the roll chart, and you couldn't make a small tube tester with a big roll chart in it. There's not enough space. 6V6. A is set to 6, which is the filament voltage. B is set to C, whatever that is. C is set to 6. It is. And D is set to E. And now you can't see it, but E is there. Rotate for shorts, otherwise it has to be on E for the test. Okay, we'll pop in the tube. And I can see the bit of wear and tear on these. We'll switch it on to shorts test. The tube should be warming up. Yep, I can see the heaters come on. Not sure where this is supposed to go. Okay, so she's warmed up. It's in the shorts position, and we'll rotate it once around and stop again at E. And we'll watch this for some indication of a short. Oh, that's as far as I can go that way. I think I'm doing this right. Back to E. Now we'll check emissions. You can see what it says. It says good. Emissions on the top, grid leakage on the bottom. We'll check grid leakage. Something I've never seen another tube tester kind of focus on, this grid leakage issue. It's in the good. There's no leakage. Tube passes. Tube out. Shorts. Tube in. I think it needs some feet. So this is a quick one too, because it's so simple. Now the other tube tester was applying different voltages to the different tube elements in some controlled fashion to maximize the correctness of the test it was doing, the emissions test. This one, I think, probably ties all the elements together, screen, plate, all the grids tied together in the plate, and then probably the current flowing from the cathode under a certain voltage will move the meter up, basically. And then they just calibrate that so they have a nice new tube, makes the meter come up in the good area. It's a really pretty simple machine, isn't it? Shorts. Oh, there's a short light here. There's a short showing up on K. K is just a letter. A, B, C, D, G, H, I, J, K. It's just a letter. Then we see a little bit of a short on the other machine in the cathode position. There's another one showing up here. Barely visible in the camera. I missed that. I was watching the meter. I should have been watching this light. What's that mean? Put it back on E. We'll do the emissions test. So this tube tester is actually quite similar to the other tube tester. The other tube tester showed the other tube higher, and this one, yeah, interesting. Grid leakage, nothing there. I'm going to put that other tube back in and do the short test again. Shorts. Now there's nothing showing up on this tube. E. Emission again. So am I supposed to be rejecting this tube because of shorts? So the way it works with pretty much everything is you get used to what you have, and you get to trust what you have, and you get to know its ins and outs of what you have. And that's so is the case for my other tube testers I've used a lot. Well, these ones, I'm not sure what I got here, especially this particular kind of tube tester. Let's go back and watch this light now. Oh, let's not do that. Let's do this. That's a bad move. I just did a bad move. Showing a short in two positions. So I'm going to put this into another tube tester that I'm familiar with. The one I showed you here. In fact, I think I can just kind of flip the camera around and keep going. Let's do that. Just flip her around to here. We're doing a 6F6. A little bit of light for me would help. 6F6. This might actually be set for a 6F6. 6.3 to 46H. Yeah, I think it is. 27345. 27345 and 5. 0610. 0610. You know, the more knobs, the more chance of making a mistake. Actually, I'm the biggest knob here, aren't I? 34. Yeah, this is all set. Lucky break. Okay, so the tube with the shorts, I'm going to put it out of this tube tester and right into this guy. Now in this case, you can read the amount of the short. You can read the short quantitatively right on the meter here. Let's see what happens. We're all set. The meter popped up just a little bit, but that's normal for every tube. So this one is not detecting any short whatsoever. Nothing happening. Tube test. So the reading is 15, 16, almost 1700, and the rejection point is only half that, 830, 830, way down here. So this tube tested really good, but this didn't test really good in the emissions tester. Yeah, too many watches. It'd be dangerous here. But no evidence of a short. There's been a little bit of evidence in the other tube tester. I mean, I got to bring all 7 of them out here. No, but I will bring one more. I'm going to bring one more tube tester out here. Not to actually use it, but just to show it. Yeah, I think it's cool. So I'm not likely to utilize this tube tester with any regularity. I'm much more inclined to use the better ones, but I certainly like the other one. The other one. Now, tubes do not have their own sort of independent or inherent transconductance. It's dependent upon the circuit that they're in, how they're being operated. Okay, let's take a look at this one here. This is a way cool one. What makes it so cool? Because of how old this guy is. So just some interesting things here. Push it back like that. It too has a chart attached right up here. When this tube tester came out to be sold, this chart was it. This is all the tubes that existed in the world. You know, the O1A, all these single number tubes, all single number tubes, 12A7 L lamp, 12A7B rectifier, don't know what that is, 12Z5. So virtually all the tubes just have a number on them. Chart of tube settings for the Electron 38 tube tester. Oh, there's a date right up here. November 20th, 1934. That's the date of the chart, and I'm sure it's probably the date of the machine. This tube tester works. It still has its grid cap. I'm not going to operate it right now. This is how you pick the filament voltage. What they do is they list the tubes over and over and over for let me pull this up. Whoops, that wasn't so good. Pull this right up here. So you can see that in red, A, B, C, D. You can see all these black. What's all this black stuff here? 14, 15, 17, 18, all the way on up, 2A5. Those are the tubes that go in this socket. In this socket, only 2 tubes go in, a 6Y5 and a 6Z5. Go into this, go into here. These aren't necessarily all different style of tube socket either. I think the same tube could fit in a number of them, but it's intended only for one for the test that's designed for that tube, I think. So you put your tube in, you set the correct voltage. How do you know? You find it on here, or you find it on the chart. So if I were to go and get a 46, if we had a 46, we would put it into, F. So F is this, F, red F. There's 46 written right there. So go in here, we'd set the filament to 2.5. We would do it in a different order. Don't put the tube in until you get the filament set. And then the potentiometer we would set to 70. Here's the potentiometer. Look at that thing. So it has these lines here sweeping around. And then it has a list of tubes out here off each line. So it's telling you if you're doing a 46, and you would find there's 46 just below my thumb there, 43, 45, 46. That's the line. So you follow it, and how do you like that? This is set to match up exactly correct. So we have the what did they call it? A rheostat? Potentiometer. So we have the potentiometer set correctly. Look, see, there's some tubes way out here. 2A7, 1A6. So now with everything tested, set correctly, you need to look at these 3 test buttons. These are actually colored, but the colors have faded. So this is actually red. I think this might be black. Oh, it says black, green, black, brown. I thought it was red. Okay, it's brown. Brown, black, and green. And how do you figure that out? Which one to push? Green, press for test. Black, second plate, if there is one. Brown, diode test. So in this case, we would be doing a 46. That's just a regular amplifier tube, I believe. So we'd be pushing this. I get a poor and a good reading up here. This is the for setting the line. There's the indicator you're supposed to make it up. This is the line rheostat. This is the, I think this is either fuse bulb in case you boob up. It's basically a dim bulb, if you like, same as what's in my shop here. And this is a neon bulb for shorts. Short test. Short test. Oh, there's a little more to this. It's a typewritten page. It's not a photocopy or out of a computer. This is the original typewritten page. So we want to know a little bit about the short test. How does that work? Short test. Tubes should first be tested for short by inserting the tube in either of the sockets having proper number of holes marked short test. Adjust the line voltage meter by means of the rheostat to the center line. If the rheostat to the center line. Rheostat. What? Whoa, whoa. Whoa. Adjust the line voltage meter by means of rheostat knob to center line. If it's shorted, small neon lamp on left of tester will burn. Burn. Well, why would they say burn? Because they're still in the day of gas lighting, of using gas lights. So, there we are. Tube test. So I think this is a really cool tube tester. Once, a long time ago, I owned one even older than this, but I was in college and really hadn't really, well, I traded it off for something else, I think, if I remember right. So there we are. This is my really old tube tester. And I have used this, and it does accurately test tubes. Again, what are you looking for? Go, no go, mainly in tube testing and this kind of work. And this kind of do it. There we are. So that's the tube testing parade for today. Tomorrow, sorry about that. Tomorrow, I'm going to put a nice radio on here, a fairly straightforward one, clock radio, and that's what I'm going to fix up. In the meantime, I have another radio that I was working on. You may have been following the series. Certainly haven't forgotten about it. But it's probably not going to get back in the shop for a little while, because I have the feeling some more stuff is going to end up here first. Great, thanks for watching, and I hope you enjoy your day, and we'll be back to radios tomorrow.